So about me, I am Pradeep Kotkar, working as a senior DevOps engineer at the Nonstop IO Technologies. So my expertise include, as Sir mentioned, DevOps, security operations, IT security compliances, cloud infrastructure operations, and data operations. So during the session, you can ask me the questions if you have. Okay. So the agenda is the Linux virtualization, containerization, networking, cloud, on-premises, cloud versus on-premises, why cloud, and which is compute storage database, and networking and security services. So first, I want to start with Linux. So the as everyone know, like Linux, we call Linux is operating system. Linux is a Linux kernel and based on Linus Torvald made the operating system, which widely used in the computers on the cloud, where every server, most of the 100% or 99% of the server use their underlying infrastructure as Linux servers. It's just like iOS, Mac OS, or other operating system. So why Linux? So so uh, why bother learning completely different computing environment? Because Linux having a no licensing cost first thing when we use for desktop and most in the cloud as well. We don't need to pay license just like Windows. It's secure and lightweight. It takes very less resources uh, like RAM, CPU, and storage as well. There are multiple flavors of Linux like Debian and Fedora. They are main two. Oh, so in the Debian, there are operating systems like Ubuntu for the security, Kali Linux, and the Fedora distribution and enterprise systems. The operating system like Red Hat and CentOS. So everyone know the Red Hat is a enterprise Linux. So for the enterprise purposes, some clients or some companies use Red Hat Linux, or some of the use Ubuntu, which are mostly free. So Linux terminal. So just as we communicate to Windows operating system by clicking the icons and things, we communicate with Linux by Linux terminal. So there is a next concept is virtualization. So what is virtualization? So virtualization is a technology that we create a virtual systems uh, relying which is on the physical infrastructure. So virtualization works using software uh, or hardware as well. So this allows us to create multiple virtual systems to run on a single physical system. Okay. Why virtualization is important? Because the first use is efficient hardware use. As if I want to make it more simple, as we use our laptop, mobiles, so we just need a 1, 2, or 3 GB of RAM, but most of the times we have systems which is capable of 16 GB, and we have storage generally 1 TB, and CPU like 8 cores, 16 cores. But as we require just a 2, 3, 4, 5 GB, then the remaining resources are getting wasted. As we have our own machines like laptop, we don't care about that thing. But when cloud providers run the large amount of system, they have to pay their electricity bills and all the related maintenance cost, even if we are not using it. So we create a virtual systems on that. So the single computer can 5 to 6 users can easily work on the same computer if we create a virtual instances of that computer. So efficient hardware use. Again, cost saving, the same thing. We have to not purchase the multiple systems. The automation, we can write the scripts where the servers can automatically start. We can mention their configurations or all these things like auto scaling and disaster recovery. So the automation is a part, scalability. So we can increase the number of instances or the size like RAM, CPU, etc. Faster recovery, just like as our system or a simple laptop takes at least half of the minute or 1 minute to start. But the virtual systems are very quickly to start. And easy migration. If you want to migrate a virtual system, we can simply dump it all the data to any storage devices and migrate it or just uh, transfer it through the internet. So this virtualization looks like there's a physical hardware that we can say that there might be a rack servers, a hypervisor installed on that, and we create a multiple computers out of that. So type of virtualization is server virtualization, desktop virtualization, network software, and storage virtualization. Uh, as as everyone use Google Drive, so it's a best example of storage virtualization. We use remote softwares. So it's a software virtualization. In the computer networks, sometimes we use the packet tracer tools or to virtualize the networks. In the computer networking labs, we use some tools to virtualize the network, and it act as the same as a physical router or switch and all the devices. The same concept applies to the cloud. We call it a software defined network. So this is a network virtualization. So we work on remote systems like cloud PC and access the with systems with RDP. So it's just a desktop virtualization, and as we use cloud, we can say it's a server virtualization. Okay, hypervisors. We use VirtualBox, VMware, or Microsoft Hyper-V. These are the hypervisors. As we sometimes create install the Linux systems or the Windows systems in the VirtualBox. So these are some popular tools we can use for virtualization on our desktop environments. So hypervisor in clouds. So Xen, KVM, Nitro, Hyper-V. These are the hypervisors used by the cloud systems. Containerization. So as the next part, Linux, we use the Linux in virtualization. Okay. After that, like if we want to package a single application, so we use containerization. So to simplify more this thing, as I want something where I want only watch the YouTube, but when I bought the system like a PC or a mobile, it provides other applications as well. I can do phone call, I can play games, but I have to pay 15-20,000. But again, the resource are wasted. But my simple use case was I just wanted to see a YouTube. So containerization, if we get a device like a iPod, previously there was a iPod, we insert a memory card and just listen the music. So we can uh, the say container, it's same like that, a container unit of software containing all the code and dependencies, and it's made for a very simple purpose or small purpose, where it is a very lightweight. And actually, it runs on the original Linux kernel or underlying systems, and it run in the operating system as a service. So Docker is widely used. The Rocket or multiple tools are used to create containers, but that's a different containerization and Docker are the different thing. Docker is a tool, and containerization is the actual concept which Docker utilizes. Why container? Uh, Environment inconsistency, like uh, we say sometimes while developing the applications, it runs on our computer, but when we zip the code and transfer it to the another or our friends systems, it get troubles running. This same thing happened in the development as well. While we develop the software with developers, so the container allows us to simply package the application and to transfer it through the network, and the same application which was running on your system will run on your friend system or any other system. Okay, it's a, as I said, it's a portable. We can simply transfer it. Fast deployment. The container run as a, just like service, like we run our the PowerPoint presentation or Chrome or WhatsApp. Container run just like a service or software. So just like we click on the WhatsApp icon and just WhatsApp pop up, even if it is completely four stops, container also start like that way, right? Just like a service. It's a cost effective, and there is a DevOps integration. It's a easy DevOps integration as when developers develop the something, they package their application in the container and simply migrate. So this will never happen that a developer is saying ki it was running on my computer, but when this deployed on the server, it failed. So these chances are very less if we are deploying the containers. So the concept microservices in the deployment, which is achieved only by containers. So this is a simple difference between virtualization and containerization, where the containers have operating system, then container engine, and we run the container just like we have Windows. Just I have Windows 10 installed, then I will install Docker on that, and then I will run container. And in the cloud, they instead of operating system, they will install the hypervisor. Then the guest OS, this all this green part will be the complete server. So, oh, as everyone know, the network, as all are the computer department, but uh, just go through just to remind me, a network is a systems of interconnected computers. So LAN, WAN, PAN, and Internet is a global network where all these topologies are interconnected to communicate each other, and that's where the cloud and we all can communicate. Basics of computer networking are protocols, port, IP addresses, MAC addresses, DNS, client server, network devices, router switches, etc. Topologies, TCP, IP, OSI model, and the layers. Now, what is cloud? So cloud is just a network of remote servers hosted on the internet that stores, manage, and process the data. And in the simple term, it's just another computer we remotely access. Types of cloud services, the basic uh, of the cloud services are the infrastructure as a service, platform as a service, or software as a service. If we if if we go this in deeper, the infrastructure as a service infrastructure, we say infrastructure as our hard disk, CPU, RAM. So when we have control to choose how much CPU we want, how much memory we want, or how much disk we want, and we utilize that service, cloud provides these services to us as an infrastructure as a service, where we have control over the CPU, memory, and the disk. Platform as a service, like when we don't have control over the CPU and the memory. So we can call it as a platform as a service, where the AWS or cloud provides us a platform where we can run our code directly. So in the infrastructure as a service, if we get create a virtual server on the cloud, then can run directly our code to the cloud. So we don't have to create the we use Gmail, Google Drive, Google Docs. Uh, these are the examples of software as a service. So even we don't have to run the code. The the cloud providers directly provide us what we want. So they sell this as a software to us. We pay them. So these are the software as a service. Okay. The cloud service model. So public cloud, the resources are shared among the multiple users, just like as I mentioned, if I run the multiple five computers and share to the five peoples. So my single laptop, which is 32 GB RAM, and I will create a five virtual machines and share among the people. My computer is shared across all the people. So in AWS, Azure, and Google Cloud, they have large servers which are interconnected to each other, and then we use in with our use cases, we create the server, storage, and all these things. So their servers are shared with us, but the actual system might be one, or so it is chances there are like me and my friend creating the servers, and might be the our both of the data stored in the same computer on the cloud. Private cloud, and we say this as on premises. So it is a dedicated infrastructure for a single organization. So why this is needed? Because the companies which involves the financial services, like banking and healthcare services, have strict regulations where on their data they don't want to store the data on the public cloud. Okay, so for those regulations, they purchase their own servers, set up the infrastructure on their labs, and create the virtual machines and virtual servers. Okay. So hybrid cloud. So when their use case, when some data is not strictly regulated and some data is regulated. So like uh, any bank want to use non-sensitive, for the non-sensitive system, they can use cloud, and for the sensitive data they want to store, they can store on their own system, and And to run this whole thing at the same time, we have to connect these the on-premises server on their company or the location. We need to connect them to the cloud. So and as this a combination of private and public clouds, we say this as a hybrid cloud. Multi-cloud. So as we know, the AWS, Azure, and GCP are the popular public clouds. There are Oracle, Alibaba as well. But in India, mostly we use this. So if there are use cases like data or the things, the Google Cloud provides some services better than AWS or Azure. Azure provides some services where like Windows-based Active Directory better than the Google Cloud and AWS provides some services better than the Google or Microsoft. So if we want to use the multiple clouds, we can, or in the high when it got high availability or redundancy, like what if get AWS the services completely get down? So the the all so sometimes customer divides the load into the multiple clouds like GCP and Azure and AWS. So in the production use cases, there are multiple use cases of a multi-cloud, but as a simple, uh, we can use multiple clouds for the same purposes. That we can say. So these are some differences, uh, difference of benefits of why to use cloud or when to use on-premises. So as I already mentioned, so why we use cloud? So scalability, cost efficiency, flexibility, disaster recovery, and collaboration. So scalability means we can simply add or reduce the resources based on our demand. So if the weekends we watch the Prime Video or Netflix more, so the companies uh, need to more compute or memory when there are multiple users, when the millions of people watch Hotstar when the match is going on, they need more resources. So we can achieve the scalability easily with cloud. So when there is a system on premises, we cannot go and purchase the servers and set up them, attach them while the traffic is suddenly increasing. In the cloud, as there is a shared hardware or shared resources, we can easily uh, scale the system. Cost efficiency, as they are a shared system, and we don't have to maintain our own infrastructure. So there is a cost efficiency as reduces the need of upfront hardware investment and operational cost. So operational cost, we can say we have to create the AC rooms, we have to install generators, pay electricity bills, okay, uh, purchase the network devices, and need expert peoples, need to hire team, and all these things. So these are the operational cost. It cloud saves all our operational costs. So disaster recovery and high availability. So cloud providers offers systems which can automatically recover even if any issue occur. Okay. So on-premises systems, when we want to do the same thing on the on-premises systems where we have our own system, we have to write our own logics. Okay. or we might need to purchase the different software or do the programming, write the scripts to achieve the disaster recovery. But the cloud provides this as a very minimal, with a very minimal cost. So high availability in disaster recovery means your system might get never down, or it's less likely will be down. So it's when the systems are softwares are down, it impacts to directly business. And even the one moment the WhatsApp or Instagram or LinkedIn doesn't work, it is a loss of millions of dollars of these companies. So how disaster recovery or availability is a most important part when we deploy the system. This is just not the availability thing, it's also part of security. So, so as a part, as a we need, our system should not get hacked, or the Facebook or Instagram or any systems should not get hacked. The same way it should not get down. Collaboration. So cloud allows us to allows multiple peoples to work on the with the networks. When we have the physical infrastructure, we have to might have to work on the single place, or it will be not easy to work collaboratively with from the remote locations. So as we cover the most of the part of the cloud and what is cloud and why it is needed, all these things. So let's go through the AWS. So what is AWS? So AWS is just a public cloud platform which offers the multiple services like compute storage, and they have the data centers globally like Mumbai, Hyderabad, Bangalore, uh, and multiple countries, USA. So this allows businesses to and developers to build, host, and deploy their applications. It provides scalability without managing the physical infrastructure. So we don't have to manage the physical infrastructure. So the services cloud provide is first thing, the compute service. So compute is when we want to run or deploy a software. So we need a computation power. So virtually cloud provides compute services like EC2. EC2 is just a elastic compute cloud. We can say this as a virtual machine or virtual computer. So EC2 is like renting a virtual computer. You choose how much CPU, memory, and storage you want, and you run your apps as just like a regular computer. You can start, stop, and resize as needed. So it supports auto recovery, load balancing, and custom EMI. So auto recovery, as I told, when something uh, issues get, just like we get the blue screen when something bad happens or something crashes. So sometimes our laptops get auto starts, or sometimes we have to set up the whole systems in some critical cases. Cloud providers provide the auto recovery facility in terms of anything get crash. So load balancing is a part of the networking, but as it load balancing works with services like virtual machines and Lambda and databases and custom EMI. So uh, we use ISO files when we set up the computers. We get ISO files, then boot the pen drive, and then install the systems. So we can create a image of our system. So AWS, on the AWS, we can also create the image of the system. So maybe in the simple language, when we have to migrate our laptop from hard disk to SSD, and by chance you purchase the Samsung SSD, the Samsung comes with the software migration. So what that software creates, it's create the image of your operating system. Okay. Then in your current hard drive, then when you attach the, and that image gets stored in some the drive, and when you attach your new SSD and restores that image, your whole operating system get restored into the new disk. And when you start working, it feels like nothing is changed, just performance has been improved. So we created the image of our whole operating system and migrated it to the another disk. So AMI, abbreviation of Amazon Machine Images, but as a AWS have this name, the other cloud providers might have different names. So with this AMI, it helps us for the auto scaling, uh, auto recovery, etc. So instance types, instance is a virtual machine. Okay. Uh, Types is general purpose, compute optimized or memory optimized. General purpose, we can say we want to develop a software or simply want to deploy a simple web server. We can say a general purpose compute like 2 GB RAM or one virtual CPU and 8 GB of storage. But if we want to run compute intensive tasks where computation is needed, like AI/ML workloads, or might be a multi-threaded application, multiple cores is needed, or so there are instances which are compute optimized. Okay, so there are different categories in the cloud of the compute optimized instances, and when we choose that instance types, these systems are highly optimized for the uh, performance. Memory optimized, so sometimes we need just more memory and not too much computation power. So we can say like this as our Google Chrome. So when you open the 10-15 tabs of your Google Chrome, it just loads your memory, but maybe when the same time you check your CPU might be 5 or 10% utilized, but your memory will be 80-90% utilized. Okay. In the cloud, like when we deploy LLMs like ChatGPT, it is a memory intensive task most of the times, as most of models are loaded into the memory, or all the data is loaded into the memory, and we just have to query from the memory, as memory is the fastest storage. So real world use cases of EC2 virtual machines or a virtual server is hosting a website, backend API, batch jobs, etc. So Lambda, uh, as there's a concept function as a service. So this EC2 comes under the infrastructure as a service, where we can choose the RAM or CPU storage we needed. The Lambda is a platform as a service. So Lambda is a serverless compute service. That means you don't need to manage any servers. So when the concept comes in the serverless or function as a service, serverless doesn't mean there is no server. It means in the cloud that we don't have to manage the server. So nothing runs without server, but in the serverless services, we don't have to manage the servers. Just upload your code and it runs automatically whenever needed. Ideal for event-driven applications, as use cases automatically resize uploaded images. Uh, when we use YouTube, when we upload video to YouTube, at first 1 to 2 minutes, it gets divided into 144p, 1080p, 4K, and 720p. Okay, so this is just an event driven. On upload it divides, and we can use the services like Lambda function, which will trigger on the upload and divide the get our video or any file, then perform the operations on it. Process form data and store in DynamoDB. DynamoDB, just consider this as a database, and on click operation, just like API, when we submit a form, it will might get data and store it in the database. Run schedule task like cron jobs, like we can say just I want to send an email. Okay, so there might be a very simple code to send an email in the PHP or Python, and I want to deploy this application on the cloud. So we can simply utilize the Lambda function instead of creating our own server, as sending an email might require a 1 or 2 MB of the resources. Okay. So what is the difference between these services? As EC2 instance, when we choose the RAM, CPU, or storage, we have to pay, as our server is continuously running on the cloud. We have to pay that bill. Okay? Either we utilize it or not, as we are using their infrastructure. But when we use Lambda, it costs us only when we are using their system. Like when I want to send 1,000 email, and the one email cost 1 rupees, and today I sent the 1,000 emails, it will cost us 1,000. And if the whole month if I do not use that, for the monthly cost, it will be only 1,000. But if I create my own server, okay, which costs us daily 1,000, at the end of the month, my bill will be 30,000. Okay, and on the same Lambda, my bill will be 1,000, as I have used only 1 day. Like, but you will say that you can run the EC2 on 1 day and then delete it. But sometimes we did not know that this will required or not. Like we have to send the emails the whole 30 days or not. The requirements are unpredictable. Auto scaling. So auto scaling, when you are as I mentioned, yes, hi Rohit. Mhm. Mhm. Okay, okay. A Lambda function has a high latency. How would you identify and multi-gauge cold starts and other bottlenecks? An EC2 bill suddenly spiked. What strategies tool would you use to identify waste, easy reserve instances, saving plans? Okay. Okay. So a Lambda function as a first thing, a Lambda function has a high latency. When you call the Lambda function, it might get a call 2-3 seconds later, right? And how would you identify the multi-gauge cold starts and other bottlenecks? So when in the cloud services, we can deploy our resources region wise, just like when the application, when the clients or people's accessing the application from the India, they will utilize the servers which deployed in the Mumbai region or Bangalore region. The latency when the customers accessing the service from the other countries, they will utilize the services deployed in the Oregon region or California region. Okay. So when the Lambda have the high latency, so current like I don't have the clear use case of the thing, but we can deploy this as per the region. Okay. And we can migrate or segregate the traffic as the network level, where you when the customer accessing the applications on the from the India, it will at the network level or load balancing level, the traffic get transferred to the Lambda function which is deployed in the Mumbai region. How do you identify the mitigate the cold starts and other bottlenecks like so I might need a more understanding on this thing, uh, but for the next question, easy to build suddenly spiked. What strategies tools would you use to identify the waste, reserve instances, saving plans? Okay. So the EC2 instances, when we deploy EC2 instances, there is a facility like reserve instances, spot instances. So we can commit to the AWS as we will use your this specific service to the 1 year, and the AWS or the cloud services will provide us the discount, just like other when we use other like monthly there is a high charge, and when we use same service yearly, it provides a discount of the 50%. Okay, but you have to pay the price on the first thing which called upfront price. So for the whole year we have to pay the price, but they will offer the discount. Okay. So the first thing in the cost saving is the like reserve instances. There are like you mentioned the saving plans. There is a full upfront, partially upfront. For example, full upfront means you want a 8 GB of server for the 1 year, and you will pay immediately for the 1 year. Partially upfront means you committed to the AWS that yes, I will use your EC2 service for the 1 year, but I will pay the bill monthly. Okay, but I will use this yearly. So for the full upfront, they will provide us the 70% cost reduction, and the partially upfront might be a 50% cost reduction will be there. Okay. Again, the cost saving strategy is a use ARM instances like your Mac computer use the ARM architecture CPUs or ARM chipset, which is very cost efficient. So cloud providers, we can use the ARM instances, and AWS EC2 bill suddenly spiked. What strategies tool do you identify the waste? Okay, so there are monitoring tools like CloudWatch. So when you use a server of 16 GB and your utilization is just a 2 GB, okay, and you have 8 virtual CPUs, but your application runs on just one vCPU, okay, and so either you have to reduce down the size of server. First thing, the the monitoring insights will provide the CloudWatch service. You might need to optimize your application to use more cores, and then if your monthly graph of the service is just a 2 3 or 10%, it's better to use a small instance and use auto scaling. If you need the more resources, it will just add a more instance, like 1 GB server is there, and if it goes 80% more than 5 minutes, the AWS autoscaling will add just another 1 GB instance to support that instance. Okay, we call this as a horizontal scaling. But if you want to increase the resources, we can do that as well, the step scaling. So I hope the doubt has solved, or if you want more explanation on the mitigate this thing, I will need more information on that. I hope thank you. You if you think, you can ping me anytime on my LinkedIn and explain me the use. If you are doing any project, I will definitely help if this is your blocker or something.
You need to think.
Thank you.
She willing to apply.
So auto scaling. So like scale up instances when CPU usage exceeded 70% or scale down when this is the example, like when in the weekends traffic get high, we might need more resources. So with the help of auto scaling, we increase the capacity of the servers. So auto scaling works with elastic load balancing. So like if I have two servers and my load get increases and there are more 3 servers added. So to divide traffic distributively, all these servers, elastic load balancer works. So which distributes the traffic, uh, uh, whichever the scaled instances appear newly. So auto scaling is just nothing but just increasing the RAM or increasing the CPU. But on the database services, it can increase the storage, and it works as other services as well, just like a Lambda function. Like as I gave the example, I want to send an email, and it will create a one Lambda function. But what if I want to send 1,000 email at a one time? So Lambda will scale its 100 instances and send those 100 emails at the same time. Vertical scaling and horizontal scaling. So vertical scaling means, as mentioned, we increase the CPU and RAM, like 1 GB RAM. For the same server, we stop that server and add the one more RAM to it and change its CPU and then run the same server. Okay. We might need when our application code is not meant to run distributively, or it's a single code need a very high computation power or high memory. Okay. But when this is not the case, we can use a horizontal scaling where the multiple instances get created of the same resources, like the 10 servers of 1 GB RAM. It's collectively a 10 GB of memory. So when we add a multiple servers, we call it horizontal scaling, and we increase the resources of a same single server, we call it vertical scaling. So storage, in the storage services, in the AWS, there are simple storage service. Uh, so storage in the AWS, they call the service as S3, and this abbreviation is just simple storage service. It's a object storage, uh, just like to store your files, like backups, images, videos, and can provide a versionings, their their life cycles, replication, and encryption as well. So just like you use a Google Drive, uh, the it's just a space like drive, but meant to be used for developers or the production application. The use cases of S3 are the simple store the data, hosting a static website, the media storage, and etc. For EBS we can call it as a C drive which is connected to our system. So when we run the servers, just like we run computer, we need a multiple disks or pen drive. So servers needs those disks. So EBS is a service on the AWS which provides the virtual disks which we attach to our virtual servers. The Glacier. The Glacier is a service AWS provides for the long-term storage or long-term backups. So Glacier is a part of S3 again, and when there is a data we don't want to access very frequently. Okay? Like for example, we store our old images into the laptop by archiving them. Okay, where we might not need to access them daily or monthly. So when there are use case of the storage, like when we don't need to access this daily, just like backups. So we use Glacier storage. It is the cheaper, cost effective, but the disadvantages are it takes more time to when we need our data. EFS, AWS, just like our network attached storage, NAS devices, the AWS provides same service with the cloud. So EFS is just a network attached storage like NAS. Uh, so what is the difference between EBS and EFS? Like this is same like our C drive, but EFS is like NAS. So the pen drive or disk we can create only to one computer, and if we want to create the same disk to another computer, we have to detach it and attach it to the another system, just like our pen drive. But network attached the file system, why we use it? Because we want to mount it into the multiple computers. So network storage, we can mount it to the multiple computers. In the latest, AWS also provides the facility to mount the EBS volume to multiple systems, but initially it was not meant for that, and that that is very exceptional use cases. But if there is a situation where you want the same drive to be mounted on the hundreds of systems or more than two systems, the EFS is the file system you will be using on the AWS. So any doubts or anything in the storage services or whatever happened till now? Okay, I'm considering that everyone understood everything. So the AWS provides us databases services like RDS. RDS is a relational managed relational database. In the relational database, we consider the PostgreSQL, MySQL, or MariaDB. So when we use the RDS databases like the Microsoft server in our Windows system or MySQL server in our the Linux systems, we have to manage the infrastructure. So like we have to install their packages and the servers in our systems, but the AWS or cloud providers provides us the direct service to us as a MySQL, where you will get only the host name of their databases and you can utilize that host name directly. So for the relational databases, AWS provides the service called RDS, which is abbreviation for Relational Database Service. For the NoSQL database, such like MongoDB, AWS provides services like DynamoDB or DocumentDB. As most of the times we use MongoDB Atlas. So, but MongoDB Atlas is again a different cloud. So, but we want to stick to the single cloud and all the communication will be in the single cloud provider. So you can use the directly DynamoDB service.
अननोन नंबरवरून व्हिडिओ कॉल येत असतील तर घाबरू नका. हे सायबर क्रिमिनल असू शकतात. 1930 या राष्ट्रीय सायबर हेल्पलाईनला त्वरित कळवा. मिनिस्ट्री ऑफ होम अफेअर्स तर्फे जनहितार्थ जारी. जर तुम्हाला पोलीस, सीबीआय, कस्टम्स किंवा न्यायाधीश असल्याचा दावा करणाऱ्या अननोन नंबरवरून व्हिडिओ कॉल येत असतील तर घाबरू नका. हे सायबर क्रिमिनल
So Aurora is the service just like RDS. It's a high performance relational database, PostgreSQL, MySQL, etc. So in the RDS, as we mentioned, MySQL, PostgreSQL, these are the community software. Community means freely utilized. We can download the MySQL server and install it our system, right? So AWS provide those services as a managed service. Okay, managed service means we don't have to install it somewhere. It will directly provide the database endpoint to us. We have to set the username, database name, password, and it's ready to go. So it's a wholly managed service. Okay. The same time, if we create the EC2 instance and then we install it on the MySQL server inside it, we have to manage their scaling and security things and create the users manually. So Aurora and RDS are why they are different is they are both relational database, but Aurora is provided by AWS itself. So they use their engines, and in the RDS they use the community engines like MySQL, Postgres, or MariaDB. Okay. Yes. Okay. So DynamoDB is a NoSQL database. DynamoDB, you can say this as a MongoDB. Okay, MongoDB. In the MySQL database, like we store the tables, tabular format where the data is structured. There are tables, rows, etc. But when there are the use case where you upload the images, the media files, and other files, okay, as well, and the data is not structured like for for your table like the name, age, or a marital status might be 2-3 fields, and there will be the another student where he might be having tens of field additional than you, like gender, the parent's name, mother name. Okay, so you both have the different structure of the data. Like when we use Microsoft Access or something, so there is a tabular format. Data is in the present in the tabular format, and there is structured. We can utilize structured query language to use it. So when there is a use case of relation, you want to store the relational data, you use a MySQL or Postgres and use the AWS service called RDS to create the MySQL instances. Same when we use case is a non-relational databases or the combination of the both the thing. you cannot create in the SQL. So you have to use DynamoDB or NoSQL database. So DynamoDB is a NoSQL database or key value store. Key value means that like just like in the relational database there are rows and tables. In the NoSQL database, you store the data in the key value format. That's why it's called sometimes called key value store as well. Oh, I hope the doubt is clear. Okay, and there is one thing, like as I told, RDS and Aurora might be the same thing, but the MySQL or PostgreSQL are the community versions, or the MySQL mostly first was open source, then it it got closed. Like so, they have some limitations in terms of scaling or clustering. So when there is a TB of data, okay, the the MySQL might have their limitations, but AWS identified those limitations, worked on it, and created their own system where there might be MySQL have the 15 terabyte of the limitations when we use AWS. But in the Aurora, they have optimized the things and created their own systems, and the limits got increased. So as they have created, it, their service provides more high performance, and also this is compatible with RDS. Like if we created systems in the Aurora, or if you want to migrate from the RDS to Aurora, you can dump data and transfer it to the Aurora. So it is also compatible with the RDS or the MySQL service deployed by RDS service. The networking services, like just like a normal network, we have our router and the switches. So in the AWS as a cloud, uh, AWS cloud provides virtual networks. So in the AWS, it called in the AWS service called VPC, Virtual Private Cloud. So which is the network inside AWS. All is a virtual networks, a software defined networks, which act same like as our physical network. You can define the IP ranges, subnet, route tables, NAT gateways, security on the VPC. You can connect it to the on-premises systems or your computer. The use cases can say you can run the instances in the specific network, okay, or the every system you will deploy in the cloud will have the network, and it will be a virtual private network in the AWS. If you create a new account, it will also have the default own virtual private cloud. Okay. So any resource like EC2 you will create, it will the AWS will assign the IP address to it, and it will provide from their virtual private network. So it's a virtual, so mostly that's why maybe it's called the virtual in the name. But in the other services, they also called is the network or something else. So elastic load balancing. So uh, just we scale the traffic when there are more traffic on our systems. So only scaling is not is not sufficient. On the newly added servers, the traffic should be distributed equally, okay, equally or or wherever the server is not utilized. So there are algorithms like round robin. So there are multiple load balancers algorithm which whatever the required or what we define, the load balancer uh, distribute the traffic as per the requirement. So it plays the roles in the high availability and fault tolerance. So load balancer not only distributes the traffic but also provides the high availability. So consider if the 10 servers are there and suddenly 2 servers stopped working. Okay, so load balancer will stop sending the traffic to those servers until they get recovered. Okay, and after they recovered or get healthy, AWS load balancer or elastic load balancer will check uh, if they can able to handle traffic by AWS health check, and then it will start transferring the traffic on that. There are types of load balancers are application load balancers and the network load balancer. So as application level protocols like HTTP, HTTPS, when we want to transfer the or balance the requests like HTTP, we use application load balancer. So these are the application level protocols. But when there is a use case where we have to transfer the network, like in the application, we can consider there are 10 users are accessing the 2 servers. Then at application level, load balancer might transfer 5 requests to one server and 5 requests to another server. But in the network load balancer, when there is a continuously 1 GB of traffic on the server, so this is a network level thing, and you want to transfer the 1 GB of traffic to the one server and like half of GB traffic to the one server and half of GB to the another server. That half of GB might contain the number of requests might different, or in this half GB there might be only single file. Okay? So these are simple use cases of the network load balancer and application load balancer. The application load balancer, as its name, it works on the application level protocol like HTTP. And network load balancer work as a network. So application is a layer 7 and network is the layer 4. So use cases of the load balancer are distribute the web application traffic and distribute it to the multiple servers. Okay. So networking service includes Route 53. So just like GoDaddy or Namecheap or other domain providers, they also provide the domain name services. Like so when we hit the google.com, it resolves the IP address of Google. Then we get connected to the Google servers, and then response the server respond to our request. So what the domain converts to the IP address DNS service, same does that only, but the AWS provides its own service with the better features. So if you there is services like GoDaddy, Cloudflare, they also provides the DNS service, but specific to AWS Route 53. So AWS Route 53, when you deploy the applications in the cloud, there are easy integration with the Route 53 service. So we can maps the resources directly with the Route 53. You don't have to go to the GoDaddy or Cloudflare and get the IP address of server and do it there. In the AWS, you can simply configure the root 53 and say that the u81.pict.ado.in will get attached to the this load balancer, which itself in the AWS service. Okay. Also, the root 53 provides the other services like load balancing or fault tolerance over the domain DNS level. So there are chances when you are your website or application using the some other the DNS service, they might not have the option to balancing the load at the DNS level. But AWS have also that capability. Also on the regional level, AWS Route 53 can also migrate the traffic on the region level, just like if someone is accessing from the Pune, okay, they will get redirect to the another server, and someone is accessing from Mumbai, they will get redirected to the another server which is near to their location. So this capability AWS Route 53 can provide you, and we have to configure it to that way. So CloudFront is a content delivery network. As a content delivery network, we can say the storage, or when we need something which should be available very quickly. Okay. And not every time you have to call to the server. So CDN is the largest CDN. We can say the Cloudflare or Alibaba Cloud, but the CDN is just some cache our data, which is we access very frequently and provide us the edge location from our edge location. Okay. So content delivery network is a global network, and CloudFront is the service AWS utilize, or we utilize from AWS to provide the content delivery network. So in the websites, we use images or media files, okay, and large files. So they does not need to be accessed each time from the server when we call them multiple times. So CDN just cache them to your nearby location, and when you access the next time or multiple times, the CloudFront or the content delivery networks provide to you those files from the nearest location. Okay. Now the security services. So there are multiple security services in the AWS, but at this or simplest level, the security groups just like our firewall. So we in the Windows we have our Windows Defender firewall. So by default it allows all the traffic, but in the security groups, the same like firewall, we attach to the virtual servers like EC2 instances, and we can configure the firewall that only 80 or 443 port should be accessible from which IP address, or from all IP address, or from uh, another specific resource. So security group is just a firewall which is used for the EC2 instance or relational database service or any other services. Okay. So you consider security groups just like firewall where we allows port or IP addresses. Okay. So network ACL. So ACLs are the access control list. As I said, the firewalls works directly. We connect firewall to the instances or virtual machines. But what if we want the protection or security at the network level? So you are in the college and you have your computer have the firewall which blocks the antivirus or malicious code. But at the network level, at or your router, you want the same facility in your router, okay, or your network or subnets. There are access control lists which we utilize to control the traffic at network level or subnet level. Okay, so the main service which mostly we use for the collaborative work is identity and access management, control access to the AWS service. So when I have a AWS account and I want to give the access to someone else, I can create its IAM user, just like a Windows user, allow him a specific access. So he will only able to access those specific services. Also, identity and access service, like its use cases. What if I created a virtual machine, okay, virtual server, and the same I have created a S3 bucket for the storage. Okay, I have created a Glacier, and I have created multiple services, multiple storage instances like ABC, XYZ, etc. Okay, and my EC2 want to, like a server want to get the data from ABC bucket or ABC folder. So we can create a policy in the IAM and allocate that policy, allocate that role to the server, where we can mention this server should be able to access to the only data from the ABC bucket or ABC folder. Okay. So this is a use case where we enforce the IAM as a resource level. We can create the multiple users and share the access and say them that this is our billing department. This person should have only access to the billing, can check only the billing and pay the bills. The another person is the monitoring department. So from monitoring person, so he should be only able to check the how much CPU is utilized. So he should not be able to stop the server and start the server. So he should be only able to monitor the resources. So we can create a separate user, create a policies that that person is a monitoring person, and this should be able to only check the utilization. So with the help of identity and access management, we can set those permissions and create those permissions. The same service in the Azure, we say Active Directory, okay, or Microsoft Intra ID. So this is same as IAM in AWS. So KMS, Key Management Service. So when we create a SSH keys or want to create a key value pairs, okay, or store any use cases where the encryption key. So everything in the AWS we encrypt. So at the security level, KMS why is important as every service like for the storage and EBS and Lambda. AWS have its own encryption decryption key, or we can create our own as well as, and we can send that customer managed keys, which AWS create. They have their self managed or AWS managed keys, where with those encryption and encryption keys, our data get encrypted. So those key service are virtually virtual service AWS provides us with AWS KMS. Okay. So there is a service, WAF, Web Application Firewall, which protects web apps from attack. Now, this looks like same as the security group, but it's not. In the security group, we can allow the port, like the 80 port should be only accessible from this specific system or this specific IP address. Okay. We just allow or deny the ports in the security group. But and at the web application firewall, it's actually the works as a detection system where it analyzes the request is dangerous. It can analyze and block the request. So there is example like DDoS. So if someone is trying to put the 100 request on your server, so WAP will quickly analyze, or we might set the rules. If there are only 1,000 requests are coming for only single IP, then don't allow this traffic, block this IP immediately. And we set those policy, or AWS WAP already have its own policies which are intelligent to analyze which request is malicious or which can down our server or harmful our application. Which when we create a web application, when we create and attach the web application firewall to the resources, the web application firewall do the same thing for protecting the web apps from attack. Okay, so like any questions, or if allows, we'll go through the AWS services in the live AWS account. Okay. So hope my screen is visible. Yes. So this is the AWS console. You can create the AWS account or any cloud account, but as this is specific, I'm telling to the AWS. You can create the AWS account. You will get the steps on the internet, and you might have already your own for the projects and etc. So this is a overview of simple the basic AWS, where you can check the account and related information here. And as I mentioned, you can change the region from here, as I have currently in the Mumbai region. So whatever resources I will create will get created into the Mumbai's data center of AWS. And this is a simple of region. All these regions are interconnected to the each other with the AWS itself, the backbone network of AWS. So in case you get from Mumbai, you switch to the California region and want to connect this, there are already AWS networks which connected internally to those data centers. So on the compute services, we saw the EC2 instances. So it's a elastic compute cloud service where we can create a simple EC2 instance, just like we have the one already here. So we can create from here like okay, we can choose the operating system. So as I mentioned, the image or as when we boot our pen drive while setting up the operating system, we use the ISO image and boot the pen drive. Just like that, we have the images of Ubuntu server Windows Server. So Red Hat Server, Windows Server. Okay, the instance types. So there are like 578 instance types. Okay. So like T2, micro, T3. These are the general purpose. You can say here, you can see the here the network performance is low and moderate. And like if you want to compute optimized instances like C5, X-large, where you will get the 4 CPUs, 8 GB of memory, or network up to 10 GB Gbps. And as I mentioned, for the cost saving, you can utilize the ARM architecture. So this is a CPU architecture. It's a regular x86-64 architecture, and this is a ARM architecture. So in the simply why your MacBook lasts longer than 6 hours, okay, and because they don't use the AMD architecture, they use ARM architecture, which is quite cost efficient. So we can launch the AWS instances. We choose the security group here. Security group is just like as I told firewall. Okay, network. So as a virtual private network, VPC, as I mentioned the service. So this is a default VPC where VPC ID is 172.31.0.0. It's a default VPC, and there is a subnet. The subnet CIDR block is 127.31.32.0/20. Okay, so this main network is divided into the one subnetwork, as you say, 31.32. The main network is 0.0/16, and then it divided into the one subnet. Okay. You can assign the public IP address. There is a service like Elastic IP address. Just sometimes we get the static IP address for our office or our internet. Okay, this is you can configure the storage like by default it's 8 GB, and these are the even the general purpose storage EBS. There are multiple types. There are multiple options you can utilize with your use cases. So like most of the settings are by default, but as this is an infrastructure as a service, and we have control over the what CPU and RAM we needed. Okay. That's the control is here, that we can choose the instance like one vCPU 1 GB RAM, one vCPU 2 GB RAM, and if you want 13 vCPU and 72 GB RAM, 192 GB RAM, etc. So you have this control here. So next compute service was I mentioned Lambda. You can search and go to the Lambda, and these are already functions in Lambda. So like let me go to the if there is a Lambda function which monitors our site is down or not. I can show you, but sure this is here. Okay. Okay. So Lambda function just like create the create the Lambda function, start from scratch, and like it will say A, B, C, for example. So runtime, what code you want to run, like Java, .NET, Ruby, and Node.js or Python. You can choose this. You can choose the architecture. Okay, as I'm creating this in the North Virginia. Okay, and you can just create a function. Now you just have to write your code, and when you will run, okay, import. Okay, hello from Lambda. Okay, so as this is a this service infrastructure as a code and platform as a code, so you can check their build duration is 3 millisecond. Max memory used by this function is 30 MB. Okay, 120 MB is provided by default, and the it took 2.11 millisecond to run our code. Okay, so our bill will be the billing will be depend on these things. Okay, and same way when we create the service like infrastructure as a code, as every service is a pay as you go, just like this EC2 instance. Okay, so for this EC2 instance, we are getting bill of whatever the resources it having, like 4 GB of RAM. But for the function we have called here, it will only bill for the this amount of time, 3 milliseconds. Or the duration is 2.11, but rounded it's a 3. On the round up, it's 3 milliseconds. So what was our the other service was actually EBS. Okay. So Elastic Block Storage was a part of compute again, like it's a subsystem of EC2, but like Elastic Block Store. Then like you can see here, this is a volume of 50 GB of GP3, which is attached to the my instance, attached to the this EC2 instance, like stdev test gen backend. So this is a server, okay, and this is a root volume, like just like our Windows C drive, which is attached to that instance. You can create your another disk of 100 GB or something, and then can attach to the same server, and it will get if this disk is a slash, it I can mount it as as a a slash mnt or something else, and if this is a Windows server, it will attach as a D drive, E drive, F drive, etc. Okay. There's a service we saw for the object storage is S3. Okay. So, so S3 AWS, S3 in AWS is a simple storage service as their in their name. So we create a bucket, like bucket we can say, just like bucket we use for our home, and it's like a folder we create in our computer, and in that folder you will save your data. So as we saw the multiple options there, you can configure the access levels from the bucket level as well. These are the multiple AWS related. I am not going deeper down into these because like this is just overview the session, I feel. But as a default encryption, server-side encryption, S3 managed key. So this is a AWS managed. I mentioned the service as a KMS. Server-side encryption is automatically applied to the new object. So this encryption is handled by AWS side. So even this key we can configure by if we create our keys, create a KMS key, and we can use that key to encrypt our data. And as a KMS is introduced while creating, we can create the KMS keys like symmetric, asymmetric, and whatever the you we guys knows as encryption levels, symmetric, asymmetric encryption. We can create those keys. As we created the POC PSAT. So what is the difference here in the Google Drive you use and the bucket S3 bucket you use? Okay. So this is used for the to develop the deploy the application. As in the Google, the first difference is you pay as you go. Just like when you store the data, you get billed based on what data, what amount of data you have stored. Okay. You can enable the versioning. So in the management is a life cycle rule. So there might be not the advanced option in the drive like I want this amount of data only this specific time, and after that time it should get deleted. Okay. Or you cannot or not easily automate the upload download process, or you might not easily get what if any video get uploaded here, the Lambda function should call on that event and divide that uh, video into the multiple formats like 144 and 720p. So cloud provides in the S3 or any cloud service which provides a storage service like S3 or in the Azure Blob service, they have the developer level capabilities, and the storage we use like drive are very user centric or customer centric. Okay. Okay. So now you will say how it will use. Like there's a GUI console in front of me, but when we do it to the programmatically, we utilize the AWS access and secret keys, etc. So I will show that thing. Mm, okay. I think I missed the auto scaling, right? So in the EC2 service, you can create a load balancers, and there is a types like network load balancer, application load balancer, gateway load balancer, classic load balancer. These are the old. So just like simple simple, we can create application load balancers. The target group we can say target groups works in the auto scaling itself. Like if we divide the 10 servers in the two targets, like 5 in the target group 1 and 5 in the target group 2. So the load balancer will transfer the traffic to those target groups and the auto scaling groups. So with the auto scaling service, we create an auto scaling group, CPI and AWS or the load balancer when transfer the traffic to the target group. The auto scaling group register those instances in the target group, and based on that load balancer transfer the traffic to the target group. So on the first place, it might be a confusing thing, but when you start working on doing the POC in these things, POC means proof of concept or the learning thing, you will get to understand more or get familiar with this. Okay, what other services we have? Relational database services like Aurora and RDS. You can search, but I have bookmarked this here. So I switch the region. Might be we can access fast. So we can create the database like as this is a completely managed service. We just have to choose which database you want, PostgreSQL, MySQL, and don't have to worry about installation and all these things. AWS will install whatever the you required itself. That's what we call this as a managed service. You don't have to need to their patching the infrastructure and the installation thing. AWS handles that. That's called we as a managed service. So while creating AWS, like just like I select MySQL, then you can choose the template. So template is just they have done templating of selection. But for the dev test, we can deploy a single edge instance where the only one instance or one database will be deployed, and multi-aging means there will be one standby instance of the database, but we will get built for both of us. And if any issue get occur in this instance, our our request get transferred to the standby instance, and this the standby will be the replica of this database. So it's as I mentioned, they create a primary DB instance with non-readable standby instance in a separate availability zone. This status provides 99.95 uptime. So this is just for disaster recovery or security purposes. So these are the multiple deployment options are there. We can mention the database name. So as in the database also we need a CPU and RAM. But as this is a managed service, we can choose, but still this will be the managed service, and it still comes under the infrastructure as a service category. We can choose the storage, allocate the storage, and there are multiple options where we can enable the backups as well. You want to backup daily, can enable the audit log, error logs. I might be password authentication. Okay. Where is the okay? This is a master username, and I want to use self-managed password. I can mention the password. Okay. Oh, yeah. So we can create the database from using the RDS service. Other service we call Dynamo DB is a managed NoSQL database. So just like DynamoDB and Document DB. Document DB. Okay. Amazon Document DB. Amazon Document DB and DynamoDB. These are the NoSQL databases where when your use case is you want to store the non-structured data. You can either use DynamoDB or DocumentDB. And this is the same like your MongoDB, MongoDB Atlas. And yes, so the MongoDB Atlas mostly when you want to use the NoSQL database, mostly you use the MongoDB Atlas Cloud. But in the AWS, you have to use either DocumentDB or DynamoDB table. You can create a table and it will provide again the endpoint and utilize this service. Okay, let's go to the networking part. It's a VPC, virtual private cloud. As I said, when you create there is always a default network when you create EC2 instances. This was the default network, but you want to create your own network, okay, a separate network. And with all these things, so this is a extra feature AWS provided. Like I want a PIC, I want to deploy a this net, I want to create this new network, and the CIDR block will be this 10.0.0 or 10.1.0. So these two we have to use. So then this will create a large network, virtual private cloud. Inside that, this will create a subnets, or we can configure this manually as well. We assign these route tables. So route tables are the just a like the rules how we should traffic get routed, or where should get routed. So all the related component VPC subnets, route tables, networks get automatically created. But if you want own control and want to create them manually, you can create as well. If we create this, its VPC will look like this. This is a resource map. VPC, their subnets, route tables, and the network connection. Network connection, we just the internet gateway. Just like we use the network service provider or access the internet. Internet gateway is that virtual router for this network. The security group. The security group, as I mentioned or told in the EC2 service, this just like a firewall. Okay. So if I open this firewall or edit inbound rules, you can check that the port number 22 SSH is allowed from all. Custom TCP port number 8000 is allowed for all. If I want to another rule that will say the port number 80, which is HTTP, or I can mention directly port number 80, or can select the protocol here, custom my IP, or anywhere, or custom IP address like 192.168. So network IP address, and save this rule. So when this security group to the these rules get tied to that server, and security groups and have the security group. Either they allow all traffic or block all traffic, but the security group manage the or ports, outbound ports to that instance. Okay, these next service is Route 53. I think I mentioned in the network. Route 53 is just like as I mentioned, GoDaddy or DNS service, where we create a hosted zones. Hosted zones mean you can say like nonstop dot pict ed, like not in. Okay, so for all this subnet, this hosted zone, if we create this hosted zone, all the subnets like Pradeep dot nonstop.pict.adio.com. I can manage this all from this hosted zone, or might be saurabh.nonstop.pict.adio. I can manage this from here. So I can show you the live hosted zone, but it's another account. But yeah, hosted, the Route 53 is a service we utilize for the DNS management, which provides the additional features like health checks, high availability, and the traffic rules like region based routing, etc. So as a simple, a reliable way to route users to internet applications. The next service is in the security, was a security group, and WAF is the web application firewall and shield. So it's a protect your web application from common web exploits. So when we create a web ACL, in the moment, like you can choose the region or global resources, get a new description. After creation, we have to choose their rules. So managed. Okay. So these are rules like account creation, fraud prevention. So these rules cost us $10 per month, but this rule, if we attach this rule to our firewall, this will account creation, fraud prevention, or account takeover prevention, bot control, admin. So these are the rules, firewall rules. I can say the intelligent rules we apply to our to the firewall, and that firewall we connect to our resources like load balancers, CD, and CloudFront. And when the attack is happen, this system it it blocks and act as a intrusion detection system and intrusion prevention system, both. So I think we have completed our time, but pending the IAM service. I can continue, right? Or should. Okay. So the IAM service I can quickly mention, like if these are the users, okay, or Aniruddha R or something like, okay, Pradeep K. So, and if I go to the user in the Aniruddha, these are the policies attached where the Aniruddha can only access the specific services, or we have attached some specific rules. So he can only access the data from these specific buckets. Okay. Okay. So this is the identity and access management service where we can create the users, create the policies, create the policies. We create the policies, we attach policies to roles, and we assign those roles to the users. Okay. Also, we can create the user groups. This is a user level access we can manage from the IAM policies, but inter-service policy, if this is a server, okay, so I can create a role, IAM role for the separately, where this role will mention that this server should able to access data from the specific bucket, and if I attach that role to this server, this server will only able to access that that data from the from that bucket or that storage point. Okay. Yeah. Yes. So I think please ping if anything missing or any doubts you can ask me anytime. So like thank you. All the things covered from my side. If you want anything advanced, I understand. I have only covered very basic and very short overview. But if you want a deeper understanding, I can give the another session as well. So yeah.
Right, Pradeep. We plan the session according to our content or syllabus content, right? So
Yes,
we'll,
yes. I checked actually the syllabus, but I could not find any related thing where I can only specific focus to the services in the EME syllabus. But as Saurabh gave me some list of the specific services, so I tried to cover those.
cover all the services na, together. Means because the AWS is very vast, so we cannot
Yes,
focus only
right,
one thing
exactly,
deeply in the.
exactly.
Okay, right. Pradeep, our head of department, Dr. Gitanjali Madam is also in the join the join the sessions.
Hello, madam. Hello, Gitanjali, madam.
Hello, good afternoon.
Good afternoon, ma'am.
So, Pradeep, thank you very much for sparing your time, sharing your knowledge with our students. And
Thank
I'm
you.
sure this will help them in their professional life. And I really thank to you, and I hope you will continue this association. Please
Yes.
be, Bagade sir, please be in contact with Pradeep, because cloud is the requirement in everywhere. And if some students are requiring guidance for any project or something, so you can connect with Pradeep if he agrees.
Yes, sure. It's my pleasure. Okay.
Please visit offline as well sometime, PICT.
Yes, actually, last week when Saurabh was there, I had registered, but from some reasons I had to go to the home, so I missed the. Yeah.
Okay, for INC you plan to visit.
Yes.
For impetus and concepts you plan to visit.
Oh,
PICT?
sorry. From for the last week, there
Event
was an event,
for the
right?
students.
So,
Yeah.
so I
That is
was about
impetus
to.
and concepts.
Yes, I was about to come with Saurabh, but I had to go to my native home,
Okay.
which is in the
We'll make
in
it.
the.
We'll make it next time.
Yes, sure.
Virendra sir, thank you very much for coordinating all the event session. So thanks all. So if you
Yeah.
want to take final photo, you can ask audience to start their cameras.
Yes, all of you switch on your camera.
Okay, I will also get to. I will also take one.
Student, all of you switch on your
Bagade sir,
camera.
your camera is also off.
Yeah, I'm on desktop, joined through desktop.
Oh, okay. Sandeep, who is there? It is Nagnath.
Nagnath, Pratiksha.
Nagnath is here.
Arsinaz, switch on your camera, Rohit.
They might be in home attire,
Yes.
maybe.
Okay.
But I think that is okay for the online meeting.
Yes.
Okay, let it be. We two are there.
So I would extend a warm vote of thanks to our distinct speaker, Mr. Pradeep, for sharing their valuable insights and expertise with us today. We appreciate the time and effort you took to prepare and deliver the technical talk. Once again, thank you for your fantastic talk and for being with us today.
Thank you. Thank you so much, sir.
Thank you, Pradeep.
Thank you.
Thank you, Pradeep. Thank you, guys. Bye.
Bye.
Okay, that I love.
What?
Something clicked. I felt like it. Felt like the chicken. Mom! Shine, it's not going on!
ये बिट टॉरेंट क्या होता है? टॉरेंट क्या होता है? क्या टॉरेंट सिर्फ मूवी डाउनलोड करने के लिए और सॉफ्टवेयर पायरेसी करने के लिए ही यूज किया जाता है? क्या टॉरेंट यूज करने से आप जेल जा सकते हैं? इन सभी सवालों के जवाब जानने के लिए इस वीडियो को पूरा देखिए। गलत तो बिट टॉरेंट प्रोटोकॉल वर्क कैसे करता है? जब हम कोई फाइल